दिल्लीમાં ઉડારે ગુલાલ ગુલાબી રંગ કેસરિયા દિલ્હીમાં ઓડે.
So friends, namaskar. Today we will study chapter number 9, application of trigonometry. So this is the introduction section, a session. The fundamental concept I will tell you here. The fundamental concept start in chapter number 8. In chapter number 8, what is trigonometry? A question, and I have tried to give the answer of this question in different manners. So the questions, trigonometry applications is the only application of trigonometry. What we have read till now in chapter number 8 will be used here. That's why the name is application of trigonometry. So let me revise chapter number 8 but in different manner. Can you see these triangles? Can you tell what is common in these triangles? Just look it. What type of triangle these are? Guess, try to guess. Okay, you have guessed accurately, correct. Why? Let's come here. Actually, this is a right angle triangle, this is also a right angle triangle. If you want to measure, this is, let me measure, is this right angle triangle? Yes, this is right angle triangle. Is this right angle triangle? Yes, this is also right angle triangle at this place. So make it right here, right angle. This is right angle. Obviously this is not right angle, not right angle. In a triangle only one right angle is possible, 90 degree. Another one 90, 90, 180. So one here 90 degree and others 90 degree are separated in two parts, something here, something here. So it is 90 degrees, so it may be these are called, it is if you have a right angle in a triangle, means right angle triangle, these two angles are called complementary angles. Means if this is 10 degree, that will be 80 degree. If this is 20 degree, that will be 70 degree. If this is 45 degree, that will be 45 degree. Complementary. C. Actually, how do you make C? In electronic watch, C is make like this. C. One L and then this. L means this is C in electronic watch. So I take L here, this, and just for some time remove it. So it's appearing to 90 degree. So complementary means 90 degree. So these two angles are complementary, means if this is 10 degree, another will be 80 degree. If this is 20, this will be 70. This is 30, this will be 60. If this is 40, this will be 50. If this is 45, another one will be 45. If this will be 60, that will be 30. If this will be 80 degree, that will be 10 degree, like that. So in trigonometry, any angles may be, while we measurement, any angles may be, but for your practice, because you are a student of class 10th, so it's only starting session in that was, yes, trigonometry was started in only class 10th. This is the first year when you are studying something. So There may be practical problems, 10 degree, 20 degree, 30 degree, 21 degree, 22 degree, every degree can maybe. But this is the first year when you are being taught this trigonometry. So in whole of this chapter you will see 30 degree and 60 degree, sometimes 60 degree and 30 degree, and you think these are the same thing, and sometimes it is 45 and 45. There may be all the angles, yeah. Can you say this will be 0 degree and 90 degree? No. 0 and 90 it is not possible, because when one angle will be 0, the triangle will be line. This is not in any triangle. If one angle is 90 degree, if this is 90 degree, so if you will make it 0, this will be 90 degree. So that I have taught in detail in my trigonometry chapter number 8, trigonometric ratios of 0 degree and 90 degree. So I will not go here. 45 is very, very simple, In trigonometry, 45 is very simple. So that's why you will not find many questions of 45 degree also, but 45 will be used. 30 degree and 60 degree. So, sometimes the questions may be 30 and 60, sometimes 30 and 45, 60 and 45. So only for your simplicity, all the questions are given here 30 degree, then 60 degree and 45 degree. So sometimes 30 and 60, sometimes 30 and 45, sometimes 45 and 60. Like this, only 3 values will be used. But remember, try to understand, all types of values are possible. So that's a practical method where we get 20 degree, 21 degree, 22 degree, and all the values are found in 7th century. 7th century somewhat work was done by the Aryabhatta, and after that 7th century, 8th century, 9th century, 10th century was passed. The whole thing which you are studying now, 45, 30 degree and 60 degree, 45 especially was used in BC at the time of Pythagoras. Pythagoras was the first person who has found the height of a tower without climbing it. That's a very historical concept, 45 degree. Because 45 degree, what does it mean 45 degree? In right angle triangle and 45 means, in right angle triangle, this is, if this is a right angle triangle and this is fixed, suppose height is fixed, so this is called distance in right angle triangle. Okay, so this is height and this is distance, and that's why sometimes you will see here the chapter name is height and distance. It is given in page number 196, height and distance. The heading is there, height and distance. Then this is some minaret, or high building. It was supposed that Pythagoras has found the height of Pisa Minar. It was some inclined also. So the questions Pisa Minar without climbing it. And how has he done it? Let me tell. Minar was, suppose anything very high standing on the ground. It's maybe that the minar is not standing just like a pole. Minar may be of this or any mountain, mountain may be of this shape. So we will find this is height, and height is when you will draw perpendicular here. These dark points are not included. Height means highest point, and distance is height is this perpendicular. So sometimes a tower is there. So tower may be of this shape, this one, but you will see this is the highest point, okay, and this is the ground. So in height and distance or trigonometry, you can find the height of this mountain. Height of mountain Mount Everest was found in 1856. It is given in your book, page number 195. Application of trigonometry, height and distance. A theodolite was given here, theodolite, and something is written also. Theodolite, Great Trigonometric Survey of British India. Then during the survey in 1852, highest mountain in the world was discovered. In 1852, trigonometry was started in BC, 200 BC. Pythagoras was known about tan theta. He was not known all the sin theta, cos theta, tan theta. He was only using tan theta at that time. Not only tan, he was using concept of trigonometry, but he has not used tan. The first time tan was used and sin theta was used, sin cos and tan was used in 7th century. And the Pythagoras was in 200 BC, 300 BC. Means after the Pythagoras, 1000 years later, in 7th century, 8th century, 12th century, because in 12th century, after 12th century, from Iraq, Iran, many invaders come. Invaders means rulers came to the India in 12th century, 13th century, 11th, 12th century. So the Iraq, Iran and the Arabian, country, they have come to the India. After that, Sikandar Lodhi in history. So, and the mathematics was going on here from 7th century, 8th century, somewhat in pieces, not in, there was not any very big center of the mathematics. So, individual peoples, just like Brahmagupta, Aryabhatta, has done something. Individuals, they have made handwritten copies. So, it was not a time like this now. They can spread their knowledge very easily. No, they write and keep it in palm leaf. They teach their students. So that was time 8th century, 9th century, 10th century. When they came here, in the 10th century, the Iraq, Iran, and after that in 12th century, Europe was known. They were they came to know that India is using decimal system. Means we are using 10 digits. Zero was some people say 0 was invented by the Aryabhatta. Is partially correct. 0 was used by many other scientists also. In BC, Pythagoras, Aryabhatta was in 7th century, 8th century, but he has done many work about the 0, how to write, how to multiply, how to divide. So that's why he or many others are given credit. Sridharacharya was also in 8th century. Sridharacharya, chapter number 4, quadratic equation, 8th century. So India was in enough good condition at that time. The Harsh period and Samudragupta, Gupta period. Gupta's period from the 4th century to the 7th century, 8th century, and the Buddha's period means 600 BC to this Gupta period, and after that Nalanda University was there, Takshashila University was there. This was that was the golden period for the India. From Buddha period 600 BC or more than that, means 1000 BC to the 1000 BC. After that 600 BC Buddha was came, and in 10th century means just like here 1000, it is now 2000 now, 1000 AD. So 1000 years, and after that 1000 years BC. So that was golden period for the India. After 10th century, 11th century, 12th century, the political condition was India is not stable. So that's why invaders and out peoples have come here, and the New Delhi was formed. Qutub Minar in 13th century, 12th century, and in 7th century. Okay. So the knowledge of Indian mathematics has spread to the Iraq, Iran, means there's some Gulf area, North Asia, I think, North or Eastern Asia, and after that they have raised to the Europe. So in Europe, 12th century, 13th century, in 13th, 14th, 15th century, the Renaissance period was started, 14th century, and they have started a press. So the trigonometry and the knowledge was spread very fast, and they have started negative number also, 0, 1, 2, 3, 4, and they started to use only 10 digits, just like Indian were using for the last 5 to 600 years. Okay, that was some history I have said in very fast way. So in my another video I will present the whole history of India, a whole history of mathematics. So this was the story in the 16th century, 15th century, when they used all the tables, 10 degree, 11 degree, 20 degree, 30 degree, 40 degree, all the, and some work was done by the Aryabhatta also. Okay, so height and distance, the time was 1852, means after 200, 300 years later when this was invented. But Mount Everest, how to find the height of Mount Everest at the time of British period, this was done in 1852. It is written here. In 1856, Sir George Everest is given credit to measure the height of the Mount Everest, Sir George Everest. So that's why the mountain is named Mount Everest, the highest. That is right now in Nepal, sometimes in Nepal, Himalaya, in Himalaya region. Okay, so the theodolite means measure angle. Measure angle means they have an telescope, and they will see the anything through the telescope. So only one line ray, line ray. Just like we whenever, how do we see anything? I am looking this fan because this is a light source. Light source is spreading light over the fan, and the light is coming back to my eyes. If I will close the this light source, I cannot see the fan. So I am seeing the fan. Light rays is coming from there. Even that is not source. So source is there. So this is. So just like sun. So how do they measure the angle? Sun is the light of source, a source of light. And it's spreading lights in all the directions. So sometimes minarets get this was the technique used by the Pythagoras. So all the lights are coming here. Yes, all the lights are coming here, all the lights, and sun is so much of big size, we cannot take as a point here, but yes. So shadow is formed, shadow of everything is formed. When all the rays of this area will get back, so this will be the shadow, and this will be the this. So this will be the length of the shadow. This at this time when the sun is here, and after that here will be all this will be lightened by the lights, but this will be the height length of the shadow. So we can measure the this length of the shadow to tell the height of minar. But in trigonometry we have read in triangles 3 things should be known. So if we know this height, this is side, and we know this is 90 degree, and if we can measure this angle, suppose it is 30 degree or 55 degree, so this will be angle, side and angle, the 3 things, angle and one side. So with the help of trigonometry we can find the height of this minar. We will measure the height, the length, height and distance of the the shadow, length of the shadow, and we can measure, we can tell the height of the minar. Suppose at any time, sun is moving around in different directions. So when the sun is arising, the height, the shadow, the length of the shadow is more when the sun is arising. At the just 12 o'clock, the suns all over the earth, the suns come on the just above the head. So at that time the shadow is 0 degree. Earlier the shadow was greater. So shadow changes according to the sun latitude and longitude, that is of trigonometry, geometry section. Yes, at that time this was the in geometry. Geometry means measurement of earth. So Aryabhatta was involved not in trigonometry. He was a Jyotisacharya who tells the future of people at what time, and he was interested to tell at what time the sun eclipse will happen, moon eclipse will happen. So they have made, and this was a very interesting phenomena done by all the peoples at that time from 7th. So trigonometry was involved in geometry, in trigonometry, trigonometry with the help of triangle, geometry, very well. Okay, so this is angle, side angle, and you will see, most of the questions 90 degrees they will not tell about. They will tell minar is there. Minar is there means it will be 90 degree most of the time. So in RHS, angle, side and angle means this is one side, this is two angles. Actually at this time we know all the angles, all the three angles. So sometimes it appears to be AAA or SAA. Actually we know all the three angles now. If we know two angles, one side, so all the three angles. So sometimes it is AAS, it is ASA. Two angles means all the three angles. Okay, so the Pythagoras, what has Pythagoras done? Pisa minar was like this, Okay, so all your questions will be of especially 30 degree, 60 degree and 45, this one only for your simplicity. And you will find in all the questions most of the times that I will tell you here, if one right angle is there, the question is only one right angle. So right angles, it is always given right angle. So only two things, one angle and one side will be given to you to find other height, other distance. Just like in your question, page number 198, come on page number 198, example number 1. So here is a tower. From the foot of the tower 15 meter, look at the figure 9.4, figure 9.4, foot of the tower, the distance is 15 meter, the angle is 60 degree, only two things. And the height we can measure, we can tell. So that is height of the tower is 15 root 3. Root 3 means that you will multiply root 3 1.7. So something you will get answer, accurate answer. So in example number 1, when you will read it, a tower stands vertically on the ground. It is written vertically means 90 degree from a point on the ground which is 15 meter away from the foot of the tower. Foot of the tower means point B. Foot of the tower 15 meter away, the angle of elevation of the top of the tower is 60 degree, angle 60 degree. So how many things are given here? Only two things, this distance and one angle. Actually 90 is given already, vertically stand. Okay, so in RHS, R matlab right angle triangle, hypotenuse and side. So right angle, it is said right angle, then only two things are required, hypotenuse and side. It may happen sometimes right angle, then one angle, then side. RAS, right angle, one angle means all the three angles, and then you may have angle, side and angle. So that's why in right angle triangle only two things are given at a time. For a right angle triangle, two things. And the questions are very simple in your example number 1. Okay, so example number 1, only one right angle. Example number 2, right angle, one right angle. So you will see 160 degree and some height is given. In example number 3, one right angle and the below side is rectangle. In example number 4, page number 200, the question is, it appears to be somewhat difficult, but it's not so much difficult. I will tell you. Example number 4, example number 5. Okay, so this was the things, okay, I am telling you 4 and 5. So this is what I am telling you. In right angle triangle, only two things, one side and one more angle, just like here, one side and one more angle is will given, and this is already assumed it is right angle triangle. So we can find the height and this is the distance. Okay, and angle of elevation means when we look at, so that's it called angle of elevation. If the observer is here, he can see the sun, he can see this one, so angle of elevation. Let me come on that point. What will I keep here? This RHS, sometimes R angle, right angle, angle and side. Means in a right angle triangle, two things should be known. One angle, in right angle triangle, two things, one angle and one side. So other things can be known. So I will erase it, all this. Okay, I will use it. So I this 30-40 degree, 60 degree, and this complementary. Yes. So let me tell what was the technique of Pythagoras to find the height of a minar at that time. You know what has he done? What has he done? A minar was there. It's not a minar, but it's an height. So you can assume this is the minar. I'm only assuming height. So he was not able to climb on the minar. So what has he done? He make a pole. Can measure the pole, height of the pole. So he has taken suppose 10 meter height. 10 meter height of the pole. And he wait. Pythagoras waiting. When the sun was like that, means it was not in same position. It may be means here and here, 3D, but it is appearing to be here. So when the sun was shining, and he was measuring the height of the length of the shadow of this pole, which he know the height 10 meter, and he is standing at 90 degree. So when the shadow was 10 meter, because the shadow will be in the starting when the sun is here, the shadow will be very large. After some time shadow goes to 12 o'clock 0, and then again the sun goes here, just like here. So when at the time this shadow was 10 meter and 10 meter, so because he can measure the height, so he was confirmed this is 45 degree and this is 45 degree, and this is right angle triangle, 45, or the two sides are equal. And at the same time, because angle, he had not any instrument to measure the angle of the sun, angle of elevation, no, but he has this technique. So this was a right angle triangle, 10 meter, and at the same time he has measured the height of the shadow of the tower. This is the height of the shadow of the tower. So this is 10 meter, so confirm this is 45 degree. And what was the height of this shadow? Suppose it was 200 meter. So he was confirmed the height of this tower is 200 meter, because he was confirmed this is 45 degree. And when the height is same here, the height will be same here also, because the sun is shining in this position. So this was used a pole and a height of the shadow of this length only to measure the angle. He had not any theodolite to measure the angle of the sun. But right now in advance in 17th century, because at that time the telescope was not made. Telescope was made in 16th century by the Galileo first time. So what has the Galileo done? Galileo has made a telescope and see the sun, or the highest point of this minar, through the telescope, and he can measure the angle. That was 45 degree. So it was easy to measure height of anything. This is 45 degree. Through theodolite he has measured the angle 45 degree, and he was sitting at the 200 distance. So this will be 200 height. So Pythagoras had to wait for the sun to be at 45 degree. But in present condition we can measure at any time the height of anything. So it's not only that we will measure the 45 degrees there. We can, it may be 40 degree here, 30 degree here, any value. So they make a chart of all the values of trigonometry. So tan theta will be used here, tan theta. How? We will solve here tan 45 degree, this one. Suppose we don't know the height of this one, so we will take x is equal to tan 45 degree is equal to tan 45 by the definition x upon 200 this. But tan 45 we have make a table. Tan 45 means this type of triangle when this is 45 degree and this is 1, this is 1, and this is 90 degree. So this was the in chapter number 8. So tan 45 1 upon 1 means 1. So if this is 1 means x upon 200 means x is equal to 200. So we will measure, we will solve like this. This was the questions in example number 1, 2, 3. Only one angle and one distance in right angle triangle. Okay. But in example number 4, what has happened? So in a right angle triangle you can measure, if you know the one angle and one side, and obviously this is 90 degree, so you can measure the height. But the question is, suppose this is not right angle triangle, can we find, and suppose this is 200 meter and this is 45 degree. Okay, just 200 meter, and sometimes we measure it 30 degree. So at that time can we find the height of this pole? Suppose we set our theodolite to measure the highest point, angle of highest point, so that is 30 degree, and we are sitting here 200 meters. So can we find the height? Yes, at any time, because we know this type of triangle in this way. This is 30 degree, this is 90 degree, and obviously this will be 1. So I have told in chapter number 8, the 90 degree is highest, so highest is 2. 30 degree is lowest, so lowest is 1. And this 1, 2, and this will be root 3. So if root 3 is 200, then 1 is equal to what? Or you can use the ratio, tan 30 is equal to, suppose you have to find h, so h upon 200. Tan 30, with the help of this, tan 30 1 upon root 3, you know this. So h upon 200, and h is equal to 200 upon root 3. H is equal to 200 upon root 3. But in class 9th it was taught not to write like this, rationalize it. Rationalize means root 2 not should be here. So multiply root 2, root 3 outside, and here 3. So this you will get somewhat answer. This one. Suppose it is 300, so you will get, if it is 200, and suppose it is 300, then you will get 100 root 3. So all of your questions will be like this. So this was the trigonometry basis. Okay. So the question is, sir, all the questions will be of right angle triangle? No. It may happen, but the solution is, any type of triangle. Now I'm going to tell you what is not written in your book directly, but I have read it in very other foreign books, foreign mathematics books.